Dear followers, this is the part 2 of the video. In the part 1, we did the movement from left to right and then back and then left to right again. And in this video, we will work on the two-dimensional movements. We will move diagonally and bounce from the walls. So let's start. I will start from the code that I have from the previous part. If you don't have this, please go back and do the first part of the exercise first. And now let's start with the following. Let's first upload this code, see that it's working. Yeah, so this is where we were at the end of the previous part. Movement from start to end, and I jump back to the start, and the direction is the same. The first thing that I want to change is to bounce from the edges instead of jumping back to the start. For that, I will do the following. I will introduce a new variable that keeps track of the direction. Let me add a comment here. There is +1 or -1. So if I move from start to the end, it's +1. If I move from the end to the start, 1 and to the back, it will be -1. And here, instead of doing +1, I will plus direction. This means that at each iteration, I will know if I'm moving one way, it will be +1. If I'm moving the other way, it will be -1. And then when I reach the edge, instead of going back to the start, all I do is I change the direction. So dir equals -1, it means the direction is the opposite. And then when the position equals 7, the difference is when this movement, I'm like 0, 1, 2, 3, 4, 5, 6, 7, and then instead of 8, I jump back to 0. But when I'm moving start to back and back to start, I reach 7, I don't want to reach 8 and go back to 7. I want to reach 7 and then already bounce back. So this is why it changes. And let's upload. See, we're almost there. Let me restart the code. We already added the boundary condition for one edge. Let's do the same for the other edge. So if position equals 0, direction equals 1. So what we added is we say when we reach this edge, continue moving start to end. So now we added bouncing. I can even add a comment here, bouncing from the end and bouncing from the start. And so what do we need to do to make this a diagonal edge-to-edge movement? What we are left to do is to copy this exact same thing and just add a second direction. And this is how we're going to do it. We're coming to the start. We're creating new variables to describe the second motion. Pose through will be 3. I want it to start here and then move diagonally. And int dir2 equals 1. Now, I'm already, this is the following that needs to be changed. Instead of row, I put pause. Instead of column, I put position 2. So I switched row and column. And then the row already works. Let's add the same code for the column. So the pose 2 is responsible for the column. So see, when the position 2 is changed by direction 2, this means that, for example, maybe it's moving from start to end for the row, but it's moving from end to start for the column. So maybe it's moving left to right, but also moving out from top to bottom. In that case, one of the directions will be plus, the other one will be minus. That's why we need individual directions for each. And then we say if pose 2 is 7, dir2 equals -1. So when I reach the when I reach the end, I bounce, and the same the second time. So let's say if this is top to bottom movement, I reached one edge and then I changed the direction of this movement. So one of the variables, this variable set, direction and position, is responsible for one of the movements. The other one is responsible for the movement in the other direction. So after I do this, I make sure that for the second part, all of the names are correct. It's position 2 and direction 2. And then I upload, and I have the bouncing from the walls. Here I have one question for you. Think what would happen if I, instead of putting this line here, I put it here. Please pause the video for a moment and think. Did anything change or no? The answer is no, and this is the reason why. So for one direction, these 3 lines are responsible. And for the other direction, these 3 lines are responsible. So if in the same direction you execute the commands in the same order, then you're independently moving in that direction. So, and this is why we avoided using for loops, because in the for loop, it would have to move from start to end and then move from this start to this end. We wouldn't be able to do it simultaneously. But here we are able to do it simultaneously. And as long as in the same movement, the order of commands is kept the same, the interchanging them between each other does not matter. For example, I would also get the exact same result if I do this. Let's make sure, let's test. Let's bring it back to a cleaner shape. It was before. So this hopefully helps to show you that when you are executing independent commands, the most important thing is to have correct order of commands in the given task. If one task is left-right movement, the other task is top-right movement, as long as you do each of them individually correctly, the only thing that actually matters is the delay, because the delay decides how long, at which stage will the program freeze for a second and you will see the dot on. So this exercise will probably be posted as a easy and medium difficulties, the first and second part. And for next week, I'll try to post a little harder examples. So thank you for joining and see you next time.